Alrighty, welcome to our study guide for our semester 2 final. We're going to do pretty much exclusively quadratics on this final. So let's take a look here. Question 1, it's just like that quiz that we took. We took a quiz called Features of Quadratics. We got that same question right here. I'll give partial credit. Each one of these, this take your time on this one, okay? It's worth a lot of points. But I'm going to give you credit for, let's say you got, at least you know how to write your standard form. I'll give you a point for that. If you know your intercepts, I can give you points for this. You don't have to get everything right. I'll look for whatever I can give you points for, so try your best on this. So let's take a look. Standard form, what they've given us here is a quadratic in factored form, right? We see these parentheses. This is factored. And this factored form is going to be really helpful for us to find our horizontal intercept. But they want us to rewrite it down here in standard form, which is useful to find this vertical intercept right here. So let's multiply these together, okay? Maybe in middle school, your teacher taught you how to FOIL, first, outer, inner, last. I'm going to do it two ways right here. I got my area model ready to go. I'm going to drag this down right here. If you're using this square, remember to line that term up with those two, this column here, the 3 goes right over there. Remember, that's a negative. When we see minus 3, we're going to be multiplying times negative 3 in this column right here. This x is lined up with that row. This 7 is lined up with that row, and this x is lined up with this column right there. Okie dokie. Let's go. X times x is x squared. If you prefer FOIL, we're just doing first. Basically, it's the same thing as all these methods are just a distributive property. We need to remember to distribute the x, multiply x times x plus 7, and then we got to multiply negative 3 times x plus 7. No matter how you do it, you end up with the same thing if you do it right. Okay, so the orange here, we got x times x. That's our first term. And then we're going to multiply these outer terms. I'll go with blue here. I got to multiply x times 7. And so on my square, that goes right here. X times 7 is 7x. I put that over here. Next, we got inner. If you're foiling this thing, negative 3 times x is negative 3x. And lastly, here, actually, yes, I should write that over here, minus 3x. And now we got our constant times our constant. This would be last. You'd multiply the 3 times the 7. And we've got to remember it's a negative 3, so it's negative 21. Minus 21. There's our standard form, okay? You might want to, if you want to simplify this, you could combine the 7x minus 3x and just call that middle term plus 4x. But I would give you credit. I'll give you full credit if you can come up with this, at least this part right here. Maybe it might look nicer if we put a y equals over there. All right, here we go. Let's go horizontal intercepts. So let's think about this. Where is my horizontal intercepts? Here's my horizontal axis, or x-axis. Goes left and right. So what am I trying to figure out to get the horizontal axis? I'm trying to think of what is going to give me 0 for y, because y is 0 right here. Any point across that line, y is going to be 0. So you know how to get 0? We use our factored form here. If we can get 0 in here, it doesn't matter what you get on this side. Anything times 0 is 0. When we multiply those two factors together, if we can get a 0 in here, anything times 0 equals 0. This is called the, zero product rule. Product means multiplication. zeros, so we get the zeros in there. And this helps us find our horizontal intercepts. So what I'm looking for is where y equals 0. I need those x values so I can put them down there on my graph. Okay, and this first factor right here, I see x minus 3. I'm just trying to get a 0 in here. If I can get a 0 in here, like I said, who cares what that is? Anything times 0 will make y equal to 0. You know what? It's going to give us a 0? 3. 3 minus 3 is 0. So if you make x equal to 3, you're going to get 3 minus 3 on the left and 3 plus 7 on the right. Okay? So 3 plus 7, you're going to have 10 over here. But that doesn't really matter because you got 0 over here. Guess what 10 times 0 is? It's 0. Anything times 0 is 0. Here comes our first horizontal intercept when x equals 3. So I'm going to plot that on my graph down here. When x is 3, y is 0. How about this next factor? How can I make a 0 in here? I'm trying to think of what x I could plug in that I could add 7 to it and end up with a 0 in here. And we got to cancel out that plus 7. So guess what x is going to be? It's going to be negative 7. Negative 7 plus 7 is 0. So negative 7. Like I said, if you plug negative 7 in here and negative 7 over here, you're going to get 0 in this factor. You'll get negative 10 over here, but that doesn't really matter because anything times that 0 over there is going to give us a 0 for y. So when x equals negative 7, 2, 4, 6, I'm thinking right there it looks like about negative 7 to me. Yep. Negative 7. Now, let's see. Where's our vertical intercept? Our vertical intercept is where x equals 0. We're trying to figure out where the graph crosses the y-axis. And every point on the y-axis, 0 equals x. X equals 0 on this whole y-axis. Okay, so let's start with that. Let's put our coordinate pair down here. X on the left, y on the right. And we're looking for where x equals 0 for that vertical intercept. So you know what this is? When we plug in 0 for x, it doesn't really matter if you plug it in here. If you plug it in here, you're going to get negative 3 times positive 7. You get negative 21. Guess where else that is? It's right here. Because if we plug in 0 for x, all this stuff is 0. All this junk over here becomes 0 when x is 0. And all you got left is negative 21. So whatever that constant term is, negative 21 is our constant term because there's no x there. It's not changing. It's going to constantly be negative 21. That is the y value of your vertical intercept. Which color should I go with? I'll stick with that green color, negative 21. Now, a lot of people get down here and they say, hey, look, there's not 21 squares down here. What am I supposed to do? I can't graph on there. Well, let's count each square as a couple units, right? We can call them 2 units each. I like 3 units each because 21 is divisible by 3. What if this is negative 3? That's 6, 9, 12, 15, 18, 21 will be down there. And here, when x equals 0, we found out y is going to be negative 21. And that's the easiest to spot from your standard form. You're also going to see it in the bottom right-hand corner if you multiply these together. Or like I said, just plug in 0 for x and then multiply that stuff together. All right. We need one more point. What's the vertex of this thing? Now, the way we find the vertex is we know that the x value of this vertex is always right in the smack dab in the middle of my 2 horizontal intercepts. So I'm looking for what's right here in the middle, and then I can figure out where my vertex is going to be. So I want to think, how far away is -7 from 3? Well, you got to go 3 to get to 0 from 3, and you got to go another 7 more. So if you add that up, these are 10 away from each other. So I'm trying to get right in the middle. When I divide 10 by 2, I get 5. I want to be 5 away from 3 and 5 away from -7. So you can just count your squares. See how many squares there are, and count how many you need to move over to get right exactly in the middle. And what I'm coming up with here is -2. -2 is 5 away from -7, and it's 5 away from 3. Maybe I'll put it down here. Hopefully it won't be in my way. So we found the x value of this vertex. It's right in the middle of 2 horizontal intercepts. But I don't know the y value. Okay, I need to take that x value. I'm going to take this -2, and I'm going to plug it in for x. You can either plug it into these two x's, which honestly I think that's your safest bet. Because let's just say you made a mistake when you multiplied these together. You could plug this into the standard form that you came up with for all your x values, but there's a small chance you made a mistake when you multiplied those together. Safest bet would be to plug it into those two x's right there and figure out what y is going to be when x is -2. So let's use that up there. Y equals, I'm going to draw a little line here so I can make sure I know that I'm working with my vertex. I'm going to take my formula, y equals x minus 3 times x plus 7. And I'm going to swap out those x's for -2. Let's trade these x's for -2. Because that's right in the middle of my 2 horizontal intercepts. So when I got that, I got to add everything up in the parentheses and then multiply them together. So y equals -2 minus 3. They're both negative. You're definitely going to end up with a negative number, and it's 5. If you got -2, you take away 3, you end up over at -5. If you struggle with adding positive and negatives, maybe use your grid over here. Think about how this is 0 and what would happen if you had -2 and subtracted 3 and how that would be -5. Maybe you could use this graph as a number line if you struggle with that. How about -2 plus 7? It's basically just 7 minus 2. We would get +5. Now, every single time you're going to see these two numbers. One's positive, one's negative, but they're the same number. There's a reason they're the same. That's because 2 is the same distance away from -3, and -2 is the same distance away from 7. So I think you should always end up with 2 of the same number. One of them is positive, one of them is negative. You know what? Actually, there's not necessarily always a negative one. Okay, if you had a negative graph, it would be positive because your y value would be positive up there. Let's multiply that together. -5 times +5. And negative times a positive is a negative. 5 times 5 is 25. So maybe I'll put that in purple. Y equals -25. Here's what I got when I plugged in that number right in the middle of my 2 horizontal intercepts. I found -2 was in the middle. I plugged it in. I know that y is going to be -25 there. So if these squares are worth 3 each, 24 is like right here. 25 will be right about there. Here's the coordinates of my vertex. When x is -2, y is -25. And I'm going to graph this thing. My graph is going to go through both horizontal intercepts, It's going to hit the vertex. It's going to go through my vertical intercept. And it's going to look something like that. So there we go. Take your time on this. It's worth a lot of points.